to Zoom. It says this meeting is now live on YouTube. Hey everybody, welcome to the Friday 3D Printing Community Hangout. Tonight we've got Paul and Chris joining, as well as a few others who are going to be joining in as well. It says just a general hangout again tonight, no topic. Hey everybody, welcome to the Friday 3D Printing Community Hangout. No specific topic tonight. We're just all hanging out, talking about what we're up to, how we're keeping busy. So, Chris, do you want to go ahead and introduce yourself?
Hey everybody, Chris here at mchrisp1 on the Twitters. 3D printing, fun time having in person. Been trying to switch the 3D printing gears a little bit as of late. Trying to get into some more personal 3D printing type projects rather than what I've been doing for the last month, which is a lot of what a lot of other people have been doing, printing things for other folks. Now I want to get back to doing a little bit of printing for me again and having fun with my printers and talk about some of that tonight. Back to you, Matt.
All right, Paul, go ahead.
Hey everybody, thanks Matt for having me on here. You can find me on Twitter where I do most of my 3D printing stuff at ppoxstellus. I am an educator. I work at the University of Maryland, so most of my 3D printing is related to educational type things. But as Chris said, over the last month and a half, I've been doing mostly PPE, and I'm sort of starting to get back into projects that I'd started before that. So unfortunately, I don't have a lot of the printed objects here, but I'll be able to tell you guys a little bit about what I'm doing with that and what I'm doing with 3D printing in the educational realm. Some fun stuff.
Cool. And I'm working on starting up some projects, different, again, like Chris and Paul, different from what I've been doing. Tonight, if y'all can't tell, we're trying to avoid a topic and we're going to do our best to. The conversation goes there, it goes there, but we're going to try to avoid it. So I'm working on with doing HVAC work. One of the things that I use a lot is a temperature probe for checking air temperatures, refrigeration, line temperatures, things like that. And in our trade, there's a popular tool made by Fieldpiece that's a dual temperature probe that allows us to check like supply and return temperatures across units and things like that, which help to diagnose issues. And they run about $120 to $150 a piece, and you have to use K-type 10K resistor probes. I want a dual temperature Bluetooth or Wi-Fi enabled device that I can leave on a job site, log things. So this morning, actually kind of last night, I started designing the electronics for it, using a ESP8266 to make my own temperature sensor that'll take different temperature probes. So I'm going to use 100K thermistors that I have as spares for 3D printers. I'm going to make it compatible with the popular K-type probes that are 10K, and then like the DS18B20s. I probably got that wrong. The digital one-wire thermistors. So I've been kind of playing with that, prototyping right now on what I need to do, working on the code to get everything working. And then that'll lead into 3D printing and some laser cutting to make the enclosures and all that stuff for it. So that's kind of what I'm starting to do to keep myself busy. What have you been working on, Chris? I know you have something to show off that you've been working on.
Oh yeah, I got a couple of things that I've been playing with. So let me get rid of the fun time background. And this is the old sliding Legolini, 3D printed crossbow, if you will. And I finally have it all together. and it is operational. It's not loaded up right now, but here, let me go ahead and slide over here and let's see here. I need to pull this up actually. It's got a safety so you can't dry fire it, but I'll slide that back. It'll catch the rope. You'll see the bow compress. So I'm not going to dry fire. So I'm going to back off and I'll let off a little dry fire, but you go ahead and you can do it 6 times real quick and pump out 6 little bolts, and it tears up a cardboard box pretty good. My backyard, it's soupy, kind of swampy with all the rain the past couple of days. A couple of darts went right through the box, and I had to pull out the metal detector and find the bolts because they were actually fully submerged in the ground. So this thing does have some power. I was taking some shots at the side of the of my shed and a old big tree in the backyard. Some of the darts stuck into it. Some of them, hit it and then fell to the ground. But it would be a good varmint blaster. If you got varmint issues, I could see it working well for that. If there's no food in the grocery stores, hey, I might become a squirrel hunter. I could see this being perfect for that. And like in the house, close quarters, home protection. It's going to be quiet. And I'll tell you what, inside of 20 feet, one of these little arrows, they're little 160 millimeter bolts. I tell you what, I saw it going through those box. This would mess somebody up inside of close quarters. This would cause a lot of pain.
That's just a sharp tip on it, right? Like not a broad point or anything like that.
Yeah, no, but it's rather sharp and pointy. And then I have seen like a flat blade type point, like
Okay.
kind of more that arrowhead.
Huh.
And those are standard bolts? Like you just just buy them?
Well, eBay, or not eBay. Well, you could get them. I got them from Amazon. They came from Shenzhen and Shenzhen and Guangdong, if I remember properly. I did 2 orders. I got 2 dozen with one order and 3 dozen with another, and I got the 3 dozen order today, and I ordered it right when all the fun COVID stuff was starting up. It was mid-March.
Chris, those are, you said 160?
160 millimeter.
Is that the actual measurement? Like, does the package give you an inches measurement? I'm just curious about something.
Nah, man.
No.
This is not high quality stuff. I'm going to give them points that they used English properly.
I'm just curious. So I just looked because we were talking about it before the stream. I have an actual mini crossbow, and I just looked up the bolts for it. They're 6 1/4 inches, which I think that measures out to your 160 millimeters. Is that what?
Do a conversion on that.
Let's see.
2.54.
6.25.
And Mike is saying, never let the machines win. He orders darts just like this from AliExpress, and
6.25 inches, 6 1/4 inches is 158.75 millimeters. So the U.S. mini bolts, and the reason I looked this up, I didn't know because the Legolini was made over in Europe somewhere.
Germany.
I didn't know if because of inches and millimeters or metric and standard, if they had a different size bolt. Like, how TVs, we have NTSC, they had PAL for their formats. I didn't know if that applied for mini crossbows, but quite apparently ours are 6.25 inches. So that'll fit in there. I was kind of curious if my bolts would work in that. So that means you can go to Dick's or Walmart and buy mini bolts.
I mean, if that's the size they've got, it should work. I mean, you can drop them in and find out. I mean, it's
Yep.
And then I did see some, what's challenging about this. So here's what's challenging about it. There's no good way to really sit this down because you got the trigger up here on this side. And then, if you close the top, the point of this is below this, so you can't really set it flat anywhere. So I noticed on Thingiverse this week, somebody came up with a stand that I think you set the bottom in and it'll stand on a tabletop or something. So I'm going to pull that design down and then remix it to make it a wall mounting piece.
Cool.
Mike says killing weapons are internationally standardized. Well, I was going to say it was an Amazon standardization.
Yeah. Yep. Yeah, because I checked. I checked against Amazon because I was thinking mine was like 8-inch bolts, but it's been a long time since I bought bolts for it. And I've lost all the ones that I had. You said about your ground being soupy and easy for the arrows to go in.
Yeah.
Yeah. Solid dry ground. They still go into the ground pretty easy. I've lost plenty of them.
Well, I'm not sure if that would always have. I mean, it was bad out there. I was standing, I could feel myself sinking in, and you can just hear the percolation all around you, the bubbles.
Yeah. So, what did you print that out of? Was it all PETG? Or
No, that's all PLA.
it is. Okay, cool.
It was not tested to use PET because of flex.
That's why I asked. I was curious about that.
Yep. I went heavy. I think the recommendation was 3 perimeters, and I did 4.
Is
and
that it?
probably.
Wow.
Pardon?
I would have actually thought more to keep it from flexing easier and give it some extra strength. So I'm actually kind of surprised that's all it was.
Yeah. No, but it seems to hold pretty well. Now, the only thing that was really. So let's see. You can see where the rubber and the rope meets. There's the end of the rope. You tie some knots in the rope, and then you shove the knot inside the tube, and then you shove it in there far enough that you have enough room to put the zip tie around, and you pull the zip tie as tight as you can, and that's what's holding that together. And then you have 2 of those junctions on each side. And I don't have, if you compare the size of the ropes or the visible rope on the top to what's on the bottom, it's not quite equal right now. So I think I have some room to play with and tweaking. But I did have one zip tie crack on me after my first round of bolts.
I bet that probably was exciting.
Well, I noticed that it was cracked.
Okay.
And I said, "Oh, let's stop playing with it. Let's replace this." So it didn't cause any issues, but I could see how it could have.
So, okay, looking at that, down at the palm of your hand, I see a skinny piece. That's the string, right?
Yep.
Now, is that like an elastic string or is that just a
polypropylene rope?
Okay, so no real stretch in it.
Correct. Correct.
No, elasticity.
Correct.
Okay.
No elasticity. Now this is really cool. Watch this part. So I'm gonna pop out if I do this right. What's the way to? Okay, that's. Yep. So this end piece, the top part, you can see the curve there.
Yep.
That piece, this prints in place.
Okay.
And after you print this part, then you stick in a screwdriver through the little hole and you pop out this part.
Oh, okay.
Which again, you can kind of see.
Oh, okay. That's making a whole lot more sense. So where'd the zip tie go?
The zip tie goes right here.
Oh, okay. There it is. All right. Now, what's the black? Is that just like a sheathing?
Exercise tubing, TheraBand.
Oh, okay. So the string is only what's there at your thumb. That attaches to. Okay, I'm with you.
Yeah, the string is just the connector of the bow to the rubber.
All right.
And then yeah, those little pieces do that in the top and the bottom. So it's got some pivot
Right.
ability in there. And again, same thing on this side.
Gotcha. So you could actually tension that up more, probably to the point of breaking, if you wanted to get more feet per second out of it.
Correct. And Mike, there is no string inside the tube. It's just empty tube in between there. And the band is called TheraBand on Amazon. I got a box of 25 feet for 10, 12 bucks, something like that. And you can use it to work out on your chair during conference calls. You just cut it in some lengths and you put some of it under your arse and you just sit here and you do some curls.
I thought you were talking exercising the bow to give while you're on your video conference.
No. I'm afraid my camera would come on and the boss would get the wrong idea.
Yeah. Make a little bit of noise and it switches to you.
Yeah, at the wrong time as I accidentally put a bolt through my foot. Yeah, we'll avoid that. But this is it's a fun little print. And I just finished it up in a hurry this afternoon because the bolts came and I was like, well, the bolts are here. I gotta go out and play with it.
So besides printed pieces, obviously you have the bolts, you have the surgical tubing, zip tie, and string. Is there any other hardware that's needed for it? Screws, anything like that?
M3x20 socket head screws and nuts, square, hex nuts.
Okay.
The zip ties, rope, rubber, glue.
That's going to be on my list of things to print because I just some of the things I was looking at there, I got an idea on modifications for that.
Well, there is a there is another. Look, Matt, you're going to be impressed twice. Let me see if I can find. Yep, there's that. Okay.
Do you know what the strength is of the tube that you got? Like how many pounds?
It's the black tube, and it's the second strongest tube. There's only one heavier tube you can go to, which is the silver.
What did you say that's called? What?
TheraBand.
TheraBand.
Where is Safari? There it is. So, are you seeing?
Yep.
Where is? They have a modification that they have parts for, and I think I'm going to print it up because it's pretty bad looking. They call it the sling bow, I think. And it's
I wonder if the long-term wear is on that, or like kind of lifespan before you have to start printing new parts.
There's the sling bow.
Whoa. So
That's
the arms and stuck them way out, so you got okay. Interesting.
and they said how did they say if you want to make a more compact, slightly stronger sling bow, it's all the same parts except it's different arms and a different grit.
It looks like they're getting strength from the arms just by putting the holes, right? So you don't need that many perimeters because you've got a lot of perimeters with all the holes, right?
Right. Yeah.
That's
Structural strength more than just less print material.
Well, that's a stronger part than if it were just printed straight without the holes.
Right. So looking at the TheraBand tubing, the black, whatever black 100% is 7.3 pounds, and 200% is 10.2 pounds. I'm guessing that maybe at full tension, it's 10.2 pounds. I'm not sure what the 100 and 200% thing is. I'm trying to relate it to the actual mini crossbows and what they trying to figure out, like how many pounds of force it has when you have it cocked.
Well, it started off as, I want to say, 2 7-centimeter pieces of rubber. And if I can find I guess I know where the big calipers are.
I really want to make one of these.
If I pull out the big calipers.
Like said, 17.3 squirrels or 1 thief before repairs. Does it have a Picatinny rail on the top of it?
It does.
Neat. I need to make one of these. What I was actually looking at with the modifications is if it would be possible to modify the original to not need the string and the zip ties. So it's just the band. So you straight through the whole way, it's one band.
So I'm stretching that piece out to 200 millimeters long.
Well, do they have the calculations?
And it did start off as 7 centimeters. So I'm going from 70 millimeters to 200 millimeters in length.
So right there, they have it up there.
Oh yeah.
Draw weight is 22 pounds, and a market mini crossbow. Let's see how many. I'm just kind of curious how this will compare to the mini crossbow that I have.
Mike, I didn't get a red dot. Well, I got a floating red dot sight, but I need to print the adapter to mount that, because if you just put it, straight on that rail, like you can see. So here's your Picatinny rail, as Matt's asking for. If you put that sight right there, when I'm looking down it, I got to look through the actual chamber where the bolts are. So they have an adapter that I think will go ahead and bring it up to about here, so it's above the chamber box, so that'll work. So Mike, if you're going to do that, look for that adapter part.
So a market mini crossbow is 28 pounds.
So this is a little less than that.
Yeah, that's 22. I mean, it's not a whole lot less.
Well, and Matt, it's to my point earlier with the length of the string, compared from one side to the other, some of that math is a little fuzzy. Right. I'm guessing that theirs was a little more cleaner made, that they did this measurement on at 22 pounds than mine. Yeah. And mine's probably a little softer. And if I wanted to, as we were talking about before, I can probably sit here and tighten up those lengths of rope, get them in tighter than what they are right now. And, you might be able to crank that up to like 26, 28, 30 pounds.
Yeah, because I remember last week we were looking, and I think these are like, the market mini crossbows are like, I think it was like 165 or 175 feet per section. And what I had seen on the Legolini, now, if I recall, I think that was the wooden one, the original version that this was modeled based on. That was claiming like 210 or something like that feet per second. So I'm like, what can we do to make this comparable?
I see a lot of ways that you can crank this thing up, and the less rope, more rubber, maybe even a little less rubber.
I I want
I
my
see lots of
to go
things.
through the scroll. Damn it.
Well, I wanted to stake it to the ground so I can, find them and,
Squirrel. That's true. Have it go
this
through.
this guy's coming in from outer space, man.
Hey guys.
Hey, Dan.
My favorite fiddler.
Thanks. I'm borrowing my dad's setup here for this stream. That's what I was Lauren when I came in here.
I saw that. I was like,
I don't know how to
coming
change this. Yep. How do you change this, Dad?
The background?
Yeah, the background.
Go down to the video. You see the little arrow?
It's pretty cool. This one.
Yeah. You see change
See, I was gonna go ahead and I was gonna match you
Oh,
there.
yep.
Dan.
There you go.
I like the one on the far right.
All right, there we go. In my natural habitat. That's my dad.
Hey, Dad.
He came to Murph
Yeah,
a
that
little
was-
while back. I think you met him, right?
Yeah, definitely did meet your dad.
Mm-hmm. So, anyway, what I missed, looks like we were talking about the bow project.
Yep.
Very cool, very cool. I've been keeping up with that a little bit. Neat stuff.
Hey, Dan. This could be fun for you and your buddies. Well, I gotta turn off the crazy background. You start losing.
Yeah,
stuff.
it's kind of, there you go. Wow.
It's and it looks really cool. Like when you're holding it up front, I called over my neighbor from across the driveway. I'm like, hey John, come here, and he's like, what? And he's like, holy crap,
What is
man,
that?
that's cool. But he didn't say crap, Matt. He said other words. I'm just pointing that out.
Is this a PG stream? We can keep it PG.
Well, I tried to.
Chris is usually the one who ruins it first.
Yeah.
I am. I admit it. But he's like, if you, I'd really like one of those. That's cool, man. He's like, if I walked outside and one of those was sitting on my front porch one day, wow. I'm like, okay, John.
Wink, wink.
I think he was dropping some hints.
Oh, he was dropping some hints for certain.
Yeah.
He's
You
like,
should
I
do
think
that.
He goes, that would just. He goes, that would just be fun for me while I'm having beers in the garage. And I'm like, well, I'm not sure about the beers part, but maybe fun in the garage.
Yeah.
No, he'll probably get one. John's a good guy, so.
Yeah, I think that's going to end up on one of my printers here very soon, if not a couple, just to get it done even faster. What was your total print time on that, Chris?
Oh, wow.
And did you print that with all standard, like 0.4 nozzle,
Yeah, 0.4.
layers, all that?
0.4, I think it's 4, and 4, tops, bottoms, perimeters. Infill was maybe 30%, I think was what their recommendation was. I think you're looking at about 30 hours of print,
Okay.
30 around there.
And how many pieces?
There's here. Let me go back to the screen share.
Is that 30 hours with just a 0.4 nozzle? You know, normal hardware, all normal kind of slicer settings, no special hacks to get it going faster.
Yeah, that's what I'm saying.
Mm-hmm.
I mean, I kind of can respect the not cutting corners too much just for speed, only because it's kind of like, well, it's got some force and a sharp object.
So here's the parts.
1, 2, 3 parts. That's it.
Well, those are the bow and the arm parts.
Yep.
This is, these two parts are what you grab onto. This is the other part on the top, and then down here at the bottom, you've got these two parts which obviously fit together into one. This part on top, you see this little tail with the thin point up here? That actually slides into this slot right here. And that kind of comes through, actually, you slide it through this piece and then it phases in there. And then this is a 3-piece for the handle and the trigger. And then up at the front, you've got this piece with the detent that holds the arrows down in the magazine.
Okay.
And those are the parts.
I noticed 3 little slots, mating surfaces, grooves in that handle there. You see what I mean?
Yep.
That's cool. Is that just to keep the two sides mated nicely?
Yep. It's part of the alignment, and he did the same thing.
That's a nice detail.
Right
Yep.
here and here.
I
You
kind of
can't
saw
see
that, but
it,
I
but it's
wasn't sure
also.
because it's, yeah.
Yep, he has the matching grooves on this piece to meet, and actually it's 3 of them, 1, 2, 3, and actually on the top 4, 5,
Oh, sure enough.
and over here you can see that they're in this piece as well. So yeah, this is a guy by the name of Lukash. If you look him up on Thingiverse, actually, I can pull that up. But he did the design, and then he even puts, if you pay attention here, how these parts are sitting. This is the arrangement, how they should be on the bed. And the reason is, somebody said if I scroll up more, yes, three sizes for the handle. But yeah, it's about getting the original bridging correct. In spots, and it's really having to do with where bridges where that arrow is going through, because you're going to have to, per the instructions down here, you see files. You're going to have to file that out to clean that, because you know as well as I do, you're not printing a perfectly nice smooth bore.
It's all right. The first arrow will clean it right up.
Yeah. There was a Nerf gun competition in one of the Facebook groups a while back, and people found that right away. Anything you print that shoots Nerf gun or bullets through air or springs or whatever is going to have issues if it's printed with the layer lines, you know.
Yeah, like if you flip that piece.
Their face normal is the same direction as that. Exactly. And then if you do it the other direction, then you get overhangs. It's like there isn't really a great way to make a smooth bore. So just about everybody except for maybe one guy used files.
Yeah.
But you know, he really thought about everything as far as, you know, how things needed to be laid out. And I mean, this document, I think it's like 80, 90 pages.
So
yeah, I'm impressed by his photo documentation.
Yeah. How often do you see something that good?
That's awesome.
And here's the extender if you want to use, you know, put the red dot sight, and it'll also allow you to mount the laser as well. And then
for laser, okay, yeah, lasers in the middle of the screen.
And RC Maniac he just put up the link in the screen there, and then this is
So it's on Thingiverse, so it is a free model. Holy crap! I was actually thinking this was a paid model.
No.
It should be. I mean,
well, you're free to tip Lukash.
Absolutely.
And they have a couple of different things for it. They've got a quick mag so that you can go ahead and fill back up real quick. And I thought I had seen they had somewhere a stand for it as well.
What else have they designed? I mean, I know like the Legolini's not there. The 3D printable version is their design based on the original. But
look at that.
That's cool. There's a stand off to the right too.
Yeah, no, I saw that stand actually when I was that's what I'm going. But look at that. That's pretty.
That looks pretty mean.
See, I kind of like that grip a little bit better than what you have, Chris, only because of the trigger position.
Yeah, it does look a bit more ergonomic.
The trigger, I hear you. Surprisingly, not so much of a deal.
Really?
It actually feels very natural when you're using. But yeah, here's the stand that I saw earlier. Look, somebody's even made a piece to go through to hold additionals.
Cool.
Yeah, because that's like on your mini crossbows. That's a pretty standard thing to have somewhere to clip more bolts too. Now they
Yeah.
also don't have a magazine holding bolts.
Yeah, well, I was gonna say if when they show this thing right here, and this is made to
Rapidly.
apparently so you can clip several onto. They had shown it in the one video.
I was thinking that was one of the rapid loaders where you take that, slam it into the bottom, and boom, all your bolts go up in.
It is. You pull
Oh,
that you pull that latch up and you put that right on top, and it drops them all in at once.
So
And
it
then-
arranges them and holds them in a stack for you and
Yeah,
supervises them, holds them in.
and then you've got your holder to put them on your belt.
It's one of those features where if you have to utilize the rapid load, you probably should practice your aim.
Uh-huh.
But yeah, it's a free model and it's cool. Somebody posted somewhere on Twitter, what's the coolest 3D, the coolest thing to 3D print, and it was
You
this.
gotta be there. Yeah.
And I was like, I need to do that. And I started it up, I guess, early March. And then shit got, I did it. Finally, Matt, I did
Told
it.
you.
What's the time? 44 minutes in.
Hey, you lasted more than last week.
Yeah.
44 minutes is pretty good.
And then stuff got crazy and it kind of went on the back burner and I wouldn't think about it so much. And then the bolt showed up today and I'm like, oh man, I got to get that together. People are going to want to see this. So it's
allowed to bring
pretty
them to
cool.
Earth?
No,
I had to ask.
absolutely positively not allowed at Earth. And yeah, Mike, and RC Maniac, I do really agree. If you go into YouTube and you do a search for Legolini, I can't remember he's a German guy. I'm gonna call him a crazy German guy. He's happy as can be, and he's all about slingshots. Slingshots for his thing, and he carved or made the first Legolini out of wood.
The slingshot channel where he laughs like this. Oh.
Daniel watches it.
I do.
He'll teach you about shooting some things with the rubber band. I can tell you that. But somebody saw his video, this kid Lou Cash, and he said, "Let me make that 3D printable," and he said, "Sure."
That's awesome. The other thought that I have in my head too is having the 3D printers plus the laser. Is what parts, how can I modify this thing to have some 3D printed parts and some laser cut parts? Because I'm thinking I might be able to make some improvements combining the two technologies. I really I got to print one of these.
Yeah, there are some things like the bow arms, the beams. You'd think those would lend themselves a little better to laser cutting. They're just structural. They don't have a lot of 3D. They're really just kind of 2D with.
Although I'll tell you, Chris pulled his back and cocked it, and the 3D printed ones, even at 4 perimeters, they flex a bit.
Really?
I mean, it's not a ton, but they definitely have some flex to them, and you want some flex. That's part of what gives you your speed.
And Dan, you might have missed this. If you see this top part here, this part actually.
Oh, isn't that cool?
And that printed.
That is
in place.
That is nice.
And the tolerance was so tight. You
built-in supports, or how did he do that?
He had a minimal air gap in the design, and you actually have to, after it's done printing, you got to put a screwdriver, or it actually works better like a 3mm Allen wrench or 2.5mm Allen wrench through there, and very carefully rock it. And then if that doesn't work, then you need to get into that curve.
Chip it loose.
I was working it with my cut gloves once, so I didn't cut myself with the razor blade, and working it just enough so that you can hear that, hear that plastic crack, and just working it, and then you put the the Allen wrench back through, and then finally it pops off.
See, I
Um,
bet you could cut that like 3 layers of plywood, 3 layers of acrylic, something, you know, one profile for the center and one profile for the cladding. It should work, right?
That's
Yeah.
kind of what I'm thinking, yeah. And Mike and I were talking in the chat. Mike had said make the bolt path channel laser cut to minimize filing to clean it out. Well, at least with my K40, I wouldn't be able to like stick that in there and cut vertically just because of the focal distance. But what I was thinking was actually that center beam part where your bolts are actually shooting through. If you laser cut that in pieces of acrylic and then bolted it all together, now you have a smooth bore going through there. Might actually, yeah. This is on my list. My very soon list.
Matt's getting excited.
Yeah, like we've talked about this for almost 50 minutes, Chris.
I'm surprised this is still the topic of conversation.
So am I. When you look at the time, I thought, holy crap, we've been talking about this the whole time. Anybody have any other questions for Chris? I want to give everybody a chance. We can come back around if we have to.
Oh, my wife played lacrosse. That's her lacrosse stick that you see back there on the wall, and it's actually signed by some well-known, she says, well-known lacrosse guy. Gary Gate, number 22. We're talking old school women's lacrosse stick. She threatens to hit me with it every once in a while if I don't clean up the mess.
Paul, what have you been up to?
What have I been up to? I painted my daughter's room. That was fun. No, that was a pain. There was a lot, once they get to be 10, they've done like a lot of like destruction. So there was a lot of sanding and patching, and so that was my big project. But as far as 3D printing stuff goes, so kind of at the top, I mentioned that most of what I do is education stuff, and being in a chemistry department, most of what I print are molecules, and I use those as teaching aids. So I set up a printing lab in our department and got a bunch of printers there to be able to do sort of volume. So like if you have a class and an instructor wants to be able to do a bunch of molecules, you can sort of set them up on bunches of printers and have those go. It hasn't been utilized that much. That's one of the hardest things I found, is that getting people recognizing that the technology is there to be able to use has been the hard part. And I finally started working with people to like kind of get it more mainstream and projects working on that. So, like just as an example, this is a buckyball. So this is a C60. So it's a bunch of carbon atoms that form the structure. And I've developed a number of ways to like make printing things like this easier. So with a Blender add-on that I have, and I guess it was just sort of the beginning of January, one of my colleagues who I'd worked with before on a project where we'd actually used a 3D printer to do 2D stuff. So we actually attached a syringe pump to a 3D printer and we're patterning things onto some of his materials that he worked with. But he's an organic chemist, and he came to me and said, well, I'm teaching a new class to graduate students on natural products. So, these are the things that you're going to find in stuff out there in nature. And their focus was on plants. So, there's a lot of stuff that goes on with ethnobotany, and, going down to the Amazon and finding compounds that are in plants and things. And his idea was to actually take the things that are around our building, and the students were going to go and identify the plants and then find compounds that were in the plants and describe them, do something with them. And he's teamed up with a woman named Andrea Ottson, who is at the FDA. She's a botanist and also an artist. So they decided, well, we should like kind of do an art project with it. And so she does stuff with plants and a variety of other things. And then they were thinking, because they were identifying molecules in these plants, that maybe what we should do is actually 3D print them. So the plan is they've identified the plants, they've identified the compounds in the plants, and now we're taking those molecules and 3D printing them on like large scales. And there's going to be sort of like a mobile art exhibit. So you can take the molecule, hang them from the tree, or put it next to the plant, put some information about it, put a QR code next to it. So as people are walking through the like sort of the garden areas around the buildings, they can, you know, bring up ID the plant, ID the compounds that are in the plants that have interesting properties. So maybe if I can, let me see if I can do a screen share here.
Cool. What kind of compounds are they doing? Like proteins, protein folding structures, or is it like simpler stuff?
Yeah, these are small molecule things.
Okay.
So
Aromatic compounds and
yeah, let me. So this is an example. Can you guys see that?
Yep.
So this is an example of some of these things. So, you know, and being in the Mid-Atlantic region, you know, you'll see these sitting around, these beauty berries. And so this is spathulinol, which is, when modified in this form, is a mosquito repellent. So, you know, their idea is that you go through and you identify these things, and then we print them. And this is just an example of some of the things. This is one that we've actually done. I've given them all of the things that I printed already, so I don't have the printed objects, but pinoresinol is an interesting molecule. It has some ethnobotany things. This is another one that we've done. So this is betulin, which is in high concentrations in birch bark. And this is the compound that you find in birch bark. The addition of one oxygen makes this betulinic acid. And so this is actually an anti-cancer agent. And then you add a few more modifications shown in red, and this now is also an HIV inhibitor. So the idea is to not just, you know, show what the compounds are in the plants, but then also have sort of, you know, modifications of those that are used in medicinal purposes. And oh yeah, this is another cool one. Cyanidin is actually, it's a pH indicator. So in these winter berries, they'll be red because they're in acidic environments. But if you take the same compound here and you move it to a neutral environment, it turns purple. And then if you move it to a basic environment, it turns blue. And so, you know, we're going to do the different, and you lose some hydrogens here and there, and the structure changes a little bit to give you these different colors of the compounds. And so we'll print them in different colors. And I was actually going to maybe hit up David Randolph and see, you can buy tons of this compound for cheap as a pH indicator, and maybe like do a run of PLA where you actually incorporate the compound into the PLA and you print it, and then you would actually have a pH sensing object, right? You could dip it into acid and it would change color. So
that's cool. One thing I would do to tweak that would be intentionally print it with a lot of surface area, you know, saturate it with water, get it totally moist, and print it all steamy and bubbly so you have a lot of surface area. That's a cool idea. I wonder what the solubility of that in PLA is.
And then what the afterwards reaction would be.
Yeah, it's going to be reasonable. I mean, I looked it up. It will survive the extrusion process, so cool. It shouldn't be too bad.
I want to see that filament.
So do I.
I haven't talked to him about it, so you know, this is just an idea that was percolating, you know, as a way that you can
do it.
You got to talk to Dave, find out how many rolls he makes in a batch, like how many rolls he'll make in one run. And I'll buy some. You'll buy some. Dan will buy some. Chris, will you buy some?
Absolutely. Hey, David's in the chat.
There he is.
Yep.
He heard his name.
Well, he's heard it now.
Well,
that
so
would be awesome, though. I think that would be cool. So a question leading on that. How sensitive is that to pH indication?
It's actually very sensitive. I don't have the pictures here, but it's It's very sensitive. Well, okay, I should say this, that there is, it's a spectrum, right? So you'll see a gradual color change over the course, but there is a point where, and you just have to know what the PK is of the group that changes, where it becomes very clear, right?
Right.
That it's
Yeah,
red
what's
versus
its
purple.
equilibrium range? Like, is it people know things like phenolphthalein is like what is that, like around 4 to 5 or 3 to 5 pH, stuff like that.
Yeah,
What's
exactly.
this one working at?
I think the acidic pH range is like in the 4 range. And then I think you got to get up to like 10 to get it blue, something like that. I don't,
Okay.
I'm sort of guessing,
Yeah.
but yeah.
Well, people can do that with household stuff. You can make a
Oh, yeah,
printed
easily.
object and dunk it in, and that's cool.
Yeah, and it's a little bit off topic to this, but the other thing that I thought would be neat was that you could take what is it, cobalt hexachloride, right, which is essentially what's in your silica, where it changes from being blue to pink.
Yep.
You could potentially put that in filament too. If you want to know if you've got moisture in your filament, well, why not see if you can just put that in there.
The solubility of that is
cyanidin, is that correct?
Cyanidin, yeah.
pH less than 3 is violet. pH 7 to 8 is blue. Oh wait, is red, less than 3. Violet at 7 to 8, and blue over 11.
Okay.
So it's got a decent range on it.
All of those things would be doable, like in a household environment. You could do that fairly easily.
That would be so cool. Dave, we want you to make some
cobalt chloride hexahydrate. Wow, yeah, that's a
and
very
Dave
drastic
said he's
color
interested
change.
in the idea too.
Yeah, the mad scientist wants to play.
Cool.
Let me just show some props.
Yeah, sorry, we kind of sidetracked your whole thing.
Yeah, no, that's fine. So this is Jeff Davis and this is Andrea, who are working on this. And I know this is kind of a terrible picture, but you can kind of see here are like sort of the size range of the molecules that we're working with. So this is the pinoresinol. This is the bitulinic acid that's over here in between, and this is the spathulinol, and I don't know, I think that's a chlorophyll down there. So, this is kind of the range, and we'd like the plan is to sort of hang them next to the plants, so it's there. And then I'm going to do, let me see, stop sharing for a second.
While you're doing that, Paul, Ron, the Happy Extruder, asked, where can we see the 3D models of those molecules? Are they STLs?
I make them STLs. I can actually show you how I do that if you wanted to see it. But then I'm going to do I don't know exactly how I'm going to do the signs, but I'm going to do some like CNC or laser, signs that has the chemical structure and the chemical formula of the molecules that are on there, and stick them along with it. So this is, I actually don't have to do any of the science on this project, which is kind of cool. I'm just the maker on it. So that's kind of fun for me in this case.
Maybe a QR code that links to the Wikipedia article burned in there.
Actually, that's going to be the students' project, is that they have to write up sort of their own description of it without taking stuff from Wikipedia, and then it'll link to the website that they've done for the class. So that's the idea, and there'll actually be sort of like a tour that you can take. So you go to the webpage and it'll tell you start here, and then you walk through and you can do all those things and see all of the different compounds and whatnot. Yeah, the STLs for these can be made available. Because we haven't printed all of these yet. But I have a sort of a workflow that I've developed for this. So you can take the coordinates that have been, so people have determined structures of these through things like X-ray crystallography. And then you can put the coordinates in one program, and then I output to Blender, and then from Blender I generate STL files. And I don't know if you want to see that, but I could.
Yeah, actually I do, because I have an idea that I might want to partner up with you on, Paul.
I'll show you. So this is an older version of Blender here, but I've written this this add-on for Blender to basically do exactly this, because the whole like one of the difficulties, right? If you're, I think you can probably still see in the video, if you're trying to do something like this, is you get tons of supports, and it makes it hard to do complex molecular structures, just either making them large, or if you have something that's complex, doing with supports. And I'm a biochemist, so I do things like proteins and DNA, and those become hard to print. So this plugin that I've done makes this easier. So this is I've already converted the molecular coordinates into an X3D file here. And so all of the carbons are, one color, the hydrogens are one color, the oxygens are another color. And I have this workflow that goes through. You can do things like, in this case, this would be a double bond, right? If you want double bonds at places. And then in order to split the molecule up so that you can either print it large or print it in flat pieces, you go through here and you can now select individual atoms and bonds. So if I select here, you notice everything changed to be one color. If I select an atom now, it's split into two colors. And essentially what it'll do now is it'll put a pin on this bond and put a hole in this atom. So when I generate the STL files, you can print these pieces independently. And like, just as an example, let's say, if I want to do, I don't know, here as well. So now this would be 3 independent pieces that you'd print separately, and then you could add, and then you can change properties, like you can change how thick the pins are and things like that. So I don't know, I'll make them thicker so they're easier to see here, how much gap room you have for these and whatnot, depending on your printer. And you can do different types of pins. So maybe I'll add one other one. I'll do something funky here. I'll make this triangular in projection. And then you just click this pin and join button. And it's pretty slow because I did all the Python scripting and it's not very good. But now this is an independent piece. Here's your pin on the bond. Here's your hole in the atom. This is the one that I did that was triangular. So now if you want to sort of key things so that you can't rotate them around, or if you want to make sure that this goes here and you can't accidentally put this here, you can sort of do these different features, right? And then the other thing that this does as well, which is actually how Prusa Slicer does their placing surfaces down, and I'm happy that I did it like 2 years before them, is that you can actually find the largest surface area, and if you just floor all the molecules, it'll put now, right, the z-axis is going up here, so it puts the largest surface area down, and this in most cases is going to give you the least number of supports when you're printing. So just automatic orientation for printing.
I don't want to miss this comment in the chat for you, Paul, because I think it might actually be a cool idea for you for your signs to go with these.
Sure.
Do you ever see the merge cubes where they have kind of like QR codes on all 6 sides of the cube? And when you hold that in front of your phone, it actually takes the cube and turns it into a 3D object, which you can use STLs and OBJ files to basically imprint on that. I think that might even be the term they use, or stamp it. So as you rotate that cube, you're looking at the molecule in your case.
Oh, that'd be
your
cool.
model. It would
What's
be
that called
neat.
again?
It's called a merge cube.
Merge cube. All
There,
right.
it's an app on your phone that you put on your phone, Merge Cube Object Viewer. And I've seen people 3D print these cubes. They're like $20 if you buy the cube, or $30, something like that. If there was a way to, well, you'd be able to 3D print it, to have a cube there 3D printed that people could rotate their phone around beside your sign, might be kind of neat.
Yeah, that's a cool idea.
So yeah, I wanted to mention that to you since Ron said it in the chat. It would be kind of neat if there's a way you can implement that. I can't talk tonight. It's a good thing when you're hosting.
Yeah, that's a neat idea. I'll have to look
I
into
think that idea is cool. I'm gonna, after the stream or else tomorrow, one or the other, I'm gonna send you a message, Paul, because I got an idea.
All right, cool.
I love Idea Man.
Hey, Scott.
How's it going, everyone?
Good. How are you?
Not bad, not bad. It's been a long couple of weeks, just trying to squash as many bugs as possible. So yeah, just taking a little bit of a chiller evening tonight as I dive into the weekend, more testing.
Hey, Scott, I have to give you credit. I've told you this before, and you've told me that, I need to change this. So you'll be happy to hear that I've been working on it. But their firmware has always been my Achilles heel. And I have Marlin 2.0 running on my FT5. I had to get a little help from my friends. Matt, you definitely gave me some help. Krusty, if you're still out there, Chris Russell, thank you. Dave, Randolph, thank you. But I got it up and running, and
Wow.
I am preparing to put it on the Robo R1 behind me, maybe this weekend if I get my things done that I want to get done. But after I did it, I said, holy crap, that was a lot easier than I thought it was going to be.
Yeah, once you get all the pieces together, it's pretty much just one button after that. It's like from now on, you just press one button, hopefully. And I'm trying to make it easier that way with like the auto build option and stuff. So,
well, thank you.
Sure enough.
You're doing the right stuff. You made it somehow. You made it easy enough for me to figure out. So,
yeah, right on. Well, what was the main challenge just getting to that point?
what was the main challenge getting to that point?
Yeah. Like working your way up to it. Just
It's just getting my mind set to that I'm going to sit down and I'm going to do this and I'm going to go through it.
yeah, right on.
I unfortunately I had a I guess my father wanted me to be a coder. Because that's what he didn't do. He that's what he wanted to do, but he didn't do with his college.
Huh.
So he decided that that's what I was going to do. And we used to go on car trips and we're going to convert regular numbers to binary, and now we're going to go from binary to hex, and we're going to go from hex to decimal. And I'm like, no, we're not doing this anymore. So
yeah, I mean, if you're not into it, you're not into it, right?
but you made it easy, so thank you, and I'll be
Cool.
quiet now.
Hey, no, I'm glad it's working. That's kind of the thing. I think I found that myself when I first got into it. I was like, what am I getting into? Look at this pile of code. But when it comes down to it, you don't have to look at most of that. That's the good thing. Unless you want to, then of course, you get lost for years and if you're not careful. So yeah, cool. I'm glad it's working. Awesome. I'm gonna try and keep making it easier, especially the configuration part, because I know, people. It's the making things discoverable is the real thing. Like you want to see right in front of you, hey, look, there's a thing, and this is what it does. And I know, and if you've never seen it before, it should be easy to get a sense of what it's about. So I want to make that help me make it more helpful that way. So we'll see how that goes.
Hey, Scott. I got a nerdy question for you later. I'm going to hold it off for now.
Okay.
But
Yeah.
I have a question that maybe you know the answer to for a project I'm working on.
All right. Yeah.
It has nothing
help.
to do with a 3D printer besides using a part for something else.
Oh, cool. Yeah, we're building plotters here now and stuff. It's fun.
Cool.
Lasers and plotters, and yeah, who needs 3D printers? You can cut and laze things now and plot them. It's great.
It's nice to have options.
Yeah, absolutely. You want to be able to either do additive or subtractive as needed.
Coming full circle.
Yeah, very much so. It seems like we're using 3D printers now to build our subtractive stuff, so we can build our additive stuff.
Right.
It really is. I mean, it's like there's that interesting synergy, right? I mean,
Yeah. And that's the question for all the geeks: is this quarantine period turning out to be a real boon like was for Isaac Newton, or are you feeling like constrained by this whole thing?
Constrained only because of current ongoing projects.
I see. You can't get together with the people you need to, and
no, just like with what I've been we're kind of trying to avoid some of these topics tonight. Like it's fine. It's bad. Don't get me wrong there.
Understandable. Sure.
But just with the current print lineup that I have going on, that's been my biggest holdup.
Mhm.
But I've kind of come to a peak on it right now, so I'm like starting to think through other projects that I need to print and starting to work towards that. So I'm starting to finally break through the constraints, so to speak,
Mhm.
and
That's cool.
So,
start to do something.
so a funny way to answer that, Scott, is I'm a person that doesn't like to leave the house for long. And, you know, this is Matt and I, we're a little bit different here. Matt will go camping and he'll, from the campsite, open up his phone and he'll fire up a print. So that print will finish 2 days from then, you know, right as he's walking and returning home from camping.
Dude, if that's the way you explain how I do things, it sounds a lot better than what I actually do.
Right?
Well, but it is. It's what you do.
No, I take the printers with me to the campground.
No,
Oh, there you go.
no, I've seen you. No, I've
Yeah,
seen you.
you're right.
I mean, I know you've done it at least once.
Yeah,
At least once.
absolutely. Yeah, I've started 48-hour prints from the campground when I got there on Friday, so that when I walked in the house on Sunday, the print was finishing as I walked in the house.
Okay. But still, so, you know, and
How'd that work out for you?
Perfect, actually. My 16-inch tall Sir Layers a lot, which at the time was the tallest one. That was started on a Friday when I got to the campground because the model was put out that day. And I walked in Sunday, walked down into my basement where my office is, and the printer was literally moving forward, presenting the part.
Ta-da!
Yep.
Perfect
I have
timing.
to play a tune at the end too, you know.
Yeah.
So I can welcome you home.
No, the tune would have been what ended up like failing the print. It would have been some bad code.
Nice.
Ram the nozzle in. Sorry.
But yeah, so I don't like to leave, you know, long story short, I don't like to leave my printers running unattended. I'll let them run below my bed while I'm sleeping all night long, and I have no problem if, you know, something happens then. But if I leave the house while I'm at work and something happens and the dogs, blah, blah, blah. So, you know, I'll leave the house and I'll go run an errand. I'll go to the Home Depot, I'll go to the grocery store. But long story short, if the printers are running, I'm home. So I don't get to run a lot of long 48-hour prints and stuff like that, because you got to time them out right, blah, blah, blah. So I've been home now for, it's over 50 some days. and I haven't done any print longer than like 8 hours. And I haven't done any cool 24-hour, 48-hour prints. I got a couple that I'd like to put through the palette and do some multicolor big prints. But no, I've printed a shit ton of PPE. And yeah, that's my second curse of the night. And I said the 3 letters.
Ton. Yeah, there's a lot of that, and we got a shipment of that, and but we haven't printed it. So we're going to be distributing what we got from China, but as far as printing stuff, it's kind of not it's not really what our machines are set up for, and we don't have a pile of filament, and but you know, they're more like test horses. So, but it's really nice. Actually, Big Tree Tech sent us a bunch of masks and things. So yeah, they've been very helpful in that way.
Ron, the happy extruder, said part of his quarantine was his wife said clean out the office closet, and then she saw all the 3D printing items and said, "Where'd you get all this stuff?" Busted.
It's been slowly filling up the closet all this time, like until now. It's like I'll take it out at once. It's just this huge ton. Nice.
Yeah, I'm very sad. I was supposed to go to Austin at the end of the month, Scott, but that is obviously canceled now. So.
Yeah. Well, hey, you know, it's basically open. Everybody's running around with no masks. So, hey, come on down. It's a party. You know, you just do what we're doing. Protect yourself. Live in a bubble. You know, it works great. But yeah, it's tricky. I mean, I imagine it would be nice if we could, you know, go on the on the highways. You figure you're safe and stuff. Yeah, those are probably the safest place to be is in your car all by yourself. You know?
Makerspace is closed.
I
It's
guess
driving
that's-
us all nuts.
Oh,
What are we gonna do? Everybody's at home doing projects, but we don't have this cross pollination that we usually do.
yeah, like those big projects where everybody's prints a part of a cow and you all ship it together and someone glues it all. If you do that now, it'd probably end up stuck in someone's basement, not being able to fit through the door.
Wait, I have one of those. What are you talking about? But if it fits out the garage door.
Oh, well, there you go.
The F3DPCH
Exactly.
logo.
Imagine,
Hey, speaking
imagine
of
if you build it in the spare room.
I don't know if I ever told anybody or not, but the F3DPCH community build logo did not survive the trip home from Earth last year.
Oh,
I don't know if I
What
ever told
happened?
you guys that or anybody
No.
besides Jen, because I was like, I can't believe this. I took it off the trailer, and when I went to pick it up, it fell into 3 big pieces and about 12 small pieces.
Huh.
It's fixed. I just glued it back together the other day.
Yay.
So
That's a
you didn't know it,
survival
but
in a
now you
manner.
do, and it doesn't matter because it's fixed. Fortunately, most of the
Well, you
parts
can't
split
tell.
on the joints and everything's went back together fine. So it's fixed.
Cool. Very cool.
Dan, what have you been up to?
Me?
Yep.
Ooh. Hold on one second.
Oh, he's got show and tell.
I don't know if he's gonna say it, but he did one thing really big as of late.
Maybe that's what he's getting.
I'll be surprised. Maybe it is. We'll see.
Scott, you guys were working while he's getting that. You guys were working on Marlin support for the K40. How's that? coming?
Yep. Real good. We just did a big push about a month ago, and that's been getting a lot of testing. There's some kind of weird issue where it doesn't turn off the laser quickly enough on the way out of like holes, so that's kind of strange. So we're trying to track that, but it now has like the M3 and M5 work the way they're supposed to, and you don't have to just use the fan commands anymore. And there's also inline options, so it's basically it can turn the power on and off much more quickly in sync with the motion. So that's basically the main thing we wanted to get, was just much more powerful control there. Some of the stuff we'd like to get in are things like buffering a raster line, so you just have a whole buffer and it just goes on off through the line at whatever spots it needs to, and then it can just do that like it can make the line wider or narrower and then do it like 5 times. That way you can basically take anything that you gave to it and make it larger or smaller as long as it's raster. So yeah, stuff like that we want to get in there, but it's getting better all the time. Yeah.
What boards are you focusing on for that?
Well, it'll work on your original K40 board if you can fit it. It'll fit on. We're using one of the CR10 boards as the board on ours for a while, but now we swapped in an STM32 board. So yeah, basically just anything that Marlin can run,
So this will work on the M2 Nano.
Things to the right pins and it'll work. On the what?
On the M2, you said it'll work on the original board, the M2 Nano.
Is that what it's called? Yeah,
Yeah.
it should. Yeah, basically as long as it'll fit. I don't know what the exact amount of memory is on that.
Yeah, that's one thing I haven't, like, my laser just works, so I haven't really screwed with it much yet, but I'm looking at making an open build platform for it. So
yeah, well, typically those don't usually come with a or do they typically come with a graphical screen or just like a regular display or no display? Like they just come with a 2-digit display, don't they?
The basic one just comes with a amp meter on it for your power, or milliamp meter, and just a potentiometer. Basically.
Okay, yeah, because ours has had like screens on it for so long.
Oh, okay, so you have the digital upgrade version. All right.
Yeah, well, yeah, we got the one with the 2 digits, and now we've swapped, and now that we've got Marlin on there, we can run any screen we want. So So yeah, basically it's looking good, and there's even like a laser icon now for the screen and everything. So yeah, it looks good. It's
Well, the screens will
coming
take a
along.
lot of the RAM, don't they?
Well, it's not so much RAM actually. The screens themselves, it's more like there is a little bit of a buffer, but it's just for like 1/4 of the screen is the
Oh, really?
buffer, because it draws it in four stripes through, so one pass each time. It'll draw 1/4 of the screen. You can hardly tell, especially because it's vertical, and so if there's tearing, you don't even notice it. But if we had like the screen sideways, you'd totally see it. But yeah, so that's kind of how it works. And so you need a not too big a buffer, but it's really the SPI communication that eats up a lot of time, because it has to be done in like the main loop, and there's delays that have to occur between the signals and stuff. And so it's the interrupts can come in the middle of that and run the steppers, but just that extra time is lost to our ability to like handle new planar blocks and things like that. So that's where the main thing is lost. But overall, yeah, having a screen on there is less costly than it used to be, because it'll throttle back if it starts to see that it's starving or whatever, causing the planner to get slow. So it's way better than it used to be. And of course, what kind of screen do you really need for most things now? And we can do special tricks like with a character display, like have it scroll over so it looks like it has multiple pages, and it actually ends up having more space than it really does or whatever. So yeah, we can do tricks and things. So yeah, it's coming along well. And I would say in general, it's also the spindle goes right with the laser. So if you are doing anything with CNC spindle wise, you also get the benefit of being able to use your M3, M5, different directions and all that with the spindle. The only thing we don't have in there is like the RPM control, because we haven't mapped RPM specifically to a different range. So we got to set it up so you can do that and say this range is this RPM. But I think we're close to that. We're pretty close. I know it displays the RPM, so I feel like it's an estimation and not perfectly accurate yet, but we'll have to look into it. I have a feeling it's just something you set and then it works.
What software are you using for G-code generation?
You can use anything. I've used for laser stuff. I've actually used Inkscape, and it has like an exporter like plugin. I've used that before. Like a rasterizer, and it works just fine. Pretty much anything, and your laser web will do it. Any of your laser oriented programs will. And if you get plugins, as I say, for anything that can do drawing, then yeah, those will all work too.
So Marlin
just tell it that M3 and M5.
Marlin would end up working with like Lightburn then.
Yeah, it should be able to reuse Lightburn as your host basically while you're running Marlin on your laser. And you should, I don't know feedback. Maybe there's certain feedback that it's expecting, like from certain software. So it might be nice to add that and have that ability. So yeah.
Neat. Sorry, I didn't mean to sidetrack away and go to laser talking.
Yeah, no, that's all right. That's all right. I'm a big fan of lasers, so
yeah, they're cool toys too.
and seeing what else this motion system. Yeah, it's definitely fun.
Yeah.
Anyway,
your work on the K40 has been like the most exciting thing about modifying the K40 that besides like the normal upgrades, like bigger laser tube and stuff that I've already done. But
yeah,
nothing against cohesion or anything, but Marlin I can get in and play with. Whereas
well, that's
how cohesion works.
That's part of it. Is just having the ability to pick any electronics you want is so nice. Right. That's one of the reasons I always liked Marlin. Was like I could see it was like on that track. It's like how many boards does it support from the beginning? Many, and now many. So yeah, it's great. So pick the one you like. That's what I say.
Yeah. Well, and the fact you said you threw a Creality board in there, I've got one of those laying around here somewhere.
Yeah, they're great. Because everybody ends up with a spare one because they're very replaceable.
Right.
And so they're perfect for this use or whatever use you want. Make a plotter.
Cool.
Yeah, I'm especially impressed because they're not known for having a lot of memory. They've had issues in the past with like, would it be the junction deviation and a linear advance and a screen? Say, you can't have all three.
Oh yeah.
That was a while back, but
yeah, they add up.
What I mean. Mm-hmm.
Yeah, they definitely add up. Some of those features are more costly than others. Like if you do add the screen, of course, that's huge because it's got all that text that comes with it. But when you're doing something like, say, junction deviation, it doesn't. It may add a couple K, so you can usually get away with adding all the cool features that make like the underlying stuff better. But as soon as you want fancy UI, that's where it's like, forget it.
Humans are expensive to machines.
Mhm,
Interacting with a
exactly.
human is a very expensive thing.
Exactly, it's that human-computer interface that costs so much.
Those damn meat puppets. Sorry, shouldn't swear.
No
It's
kidding.
interacting with those. That's the difficult part.
So what
The
did
rest
you
is
run
just
off
moving
to
ones
grab?
and
Don't
zeros
worry, in
around.
Cronenberg world, it'll.
What was that?
I asked what you ran off to grab.
Oh. Okay, let me show you. I finally got a PrinterBot Metal Plus.
Nice.
I have been lusting after this thing since they were released. My first printer was a PrinterBot Simple Metal. Still have that. It's been out of commission for a little while, but I've been trying to get my hands on one of these for a while, and it's, you know, a $1,000 printer piece of hardware. And, Jacob Ayers has one, had one laying around, hadn't touched it in a long time, and he decided to sell it to me, which is good because all of the rest of my printers are not printing right now, which is kind of a shameful state of affairs. I can't fix my printers without printed parts, and I need a working printer to print printed parts. So you got to get one to rep strap, you know, jump start the whole thing. So Jacob sold that PrinterBot Metal Plus to me, and I'm going to get that going and kind of jump the rest of my printers all off the ground here. I did my first print on it last night, the first 2 layers of a 3D Benchy, and then it broke loose because it doesn't have a heated bed yet, but I'll get there.
So you'll be ready for the speed benchy competition.
Well, not on that one, but on some other ones. Can you say 3 Gs of acceleration-ish?
Looking here, Scott's going. I'll ask Chris's question about cohesion boards and Marlin when Scott comes back. Yeah, I'm like starting to pile up my list of projects. Been meaning to break away and do something. I got a whole bunch of material for the laser to play with, to learn how to do, to learn the settings for cutting it. So I've been playing with that stuff more in the last few days.
And Dan,
Mhm.
congratulations, sir.
Thank you. It's coming up in a couple months here now. It's going to be very exciting. Very exciting.
Good for you. I look, you're gonna have to drag her out to Murph next year, or what? I look
That's
forward
the
to.
plan.
I look forward to
Once
meeting
the
her at
virus
Murph.
stuff allows.
Yep,
Buy
yep.
lots of printers now.
Yes. Yes. Yeah.
Get-
Buy, build now. Get all the hardware now, and then just say, "Oh, honey, I've always had this stuff.
Yep,
It's coming with us."
Get the toys now.
Yep. Yeah. RC Maniac 25 in the chat. This is why I wanted one reliable printer and then one toy printer. You got a point. My most reliable printers have been shifting over the years, and kind of devolving. My Core YXT or Core XYT, depending on what you call it. Chris has seen that one. That one was my workhorse for about 1.5 years, running a Mosquito Magnum on it, and I'm finally disassembling that. I have the Mosquito Magnum on the PrinterBot Metal Plus right now, but that one is getting its actual dedicated set of hardware, a Light 6 and some other inexpensive stuff. But yeah, it's a very, very interesting problem to have this many printers and be known amongst my buddies as, oh, that 3D printer nut. And yet I don't have any working ones. This is a weird problem to have.
Whatever happened to the Big Mama Jamma?
Oh, I've got that downstairs at my grandpa's house. That one is same thing. It's like 90% there, like most of my printers. They're like 90% there, but 90% there isn't 100% there. That only counts in, what do they say, horseshoes and hand grenades.
Yeah. Well, I loved it. That was Murph 2018. You and Jacob sitting on top of that thing. I brought my my 3D printed violin, and you were jamming out on top of it. It was a party,
That was
man.
fun.
And it was a trip. The two of you sitting on top of that printer. It blew my mind.
Man, that was a good time. Sanjay came over and we had shots sitting on top of the printer. Oh, I'm not supposed to say it. Can I say that? I don't know.
Yeah, that's better
was a
than,
fun time.
my language.
Yeah, it's nice to
Oh,
just
that's-
rest our feet. We're walking around all day. Murph is a trip. It's a real trip.
Shot. It's okay to say shots. It just depends on what you're shooting up. That's all.
Yeah. Yes. Oh, just like whiskey, I think. I don't
Oh,
remember.
right on.
I was so tired by that point. What a day.
Well, I would have drunk anything they handed me.
Yeah. I feel you. Yeah, man, I'm longing for the good old days of 3D printer festivals and any kind of festival, really.
The
Social.
virtual one wasn't bad, I gotta say. That was fun.
Yeah. I tuned in for a couple bits and pieces there. It was neat.
Yeah. It was like a good way for the same folks to get together and not crowd each other too badly. It was great.
Yeah, way less crowds.
Yeah.
I was going to say,
Smelled better.
this is how I get together with my family now. So, hey.
Yeah. Yeah, this might be our Thanksgiving right here.
So, Scott, now that you're back, Chris, Practical Printing, asked if you're working with the cohesion boards, Marlin support on cohesion.
Not specifically, but but let me check something. I want to just make sure. Let me see. Do I have a config for that? It's been a while since I checked my configs, but let's see. Yeah, I don't think I have a cohesion for it yet. Nah, I didn't think so. Yeah, it's still in the works. The thing is, those boards, all you need to know is the pinouts, and we could probably get that working. It just hasn't been, no one's urgently demanded it. So it just hasn't gotten pushed to the top, but it wouldn't be hard to do.
Cool. There are a bunch of them out there. I'm guessing the main reason why it's not an urgent request is that they're all hard at work and basically working, you know.
Yeah, and not
Probably
necessarily
some more of those
printing,
requests, right? Not printing. More of those requests come from like Creality boards and that sort of stuff. Where, oh man, I've got this problem I need to fix because I want to do something else with it really urgently. I don't think many of those cohesion 3D boards are in that situation.
Yeah, for some reason the laser is, even though it's like to some extent way simpler than the 3D printers are, it's like one of those, it's working.
Yeah.
The only reason I put a bigger tube on is because I burn out my smaller tube. Like, okay, now's the time to tinker because it doesn't work right now. It's been a little bit more intimidating to interrupt the fact that it works.
Lasers are a little scarier. Yeah.
So I've got a few of these here. We have, this is the Remix board here, the Cohesion 3D Remix. This one is the Cohesion 3D Remix. And this one is the Remix. So, okay, so I've got three remixes. But yeah, they're all, I believe they're all running LPC 1768 chips, and should be fairly doable. I think the stuff that we've got so much cool stuff in Marlin now. It's like, now I can actually apply it to the things that I probably couldn't have before. Like this has Wi-Fi built in. It's got, it's got the SD right on the board, all that kind of stuff. Now that should all be well sorted at this point. So yeah, I'll get this done soon, because this has been one of those things that's been an itch for a long time. So
Yeah. Do you have any other boards in Marlin that use that same processor?
oh yeah, the
Okay.
rearm board, the smoothie board. Smoothie is 1769, but your rearm, which is meant to have a just take your old
Yep.
ramps
Arduino
right on,
Mega
and
pin placement, and you just
yep. And if you've seen Chris's video in Chris's basement, he shows that you have to rewire it a little bit for the screen. But yeah, that's pretty straightforward because the pins are just sticking right on the end. And it's a really lovely board, and also it's like, it's gorgeous too. Like, you can't see it, just like, ooh, where are the traces? I can't see them at all.
Yeah.
Which is, aesthetically nice, but maybe inconvenient sometimes. But yeah, there's actually quite a few that use the LPC 1768 as a very popular chip. In fact, it's interesting because it's more pricey than the STM32s, and not necessarily, a predecessor. They've all kind of come up together. But now, of course, the STM30s is kind of taken over the scene because they're so cheap, So it's very interesting, like all the boards that are coming out from Big Tree Tech and stuff. A couple of them use that chip, and a bunch now are using the STM32 different models. And it's probably based on pricing and availability in general. You want the cheapest you can get with the most power, and other than that, just put other reliable components on there and make sure it's all well protected, and then it should be good. And I guess the boards that are based on the STM32s tend to be cheaper, that's for sure. But then there are some that are fancy, like what you got the GTM32 now. Have you seen this behemoth? Okay, so this is the board itself, which I also use as a lunch tray, and this is like, it actually comes with that's not even the board. That's the board. This is the it comes with a daughter board like this. This is the actual. So you can add another 1, 2, 3, 4, 5 steppers to it, and end stops and other things. And so overall you can run 1, 2, 3. If you had 3 axes, you could have 8 more things in addition to your 3 axes. So running on steppers, crazy. So it's huge. Yeah, it's getting a lot of testing now. It's basically made for tool changers, and those types of things.
Did you say that's STM32?
Yeah.
Or is that okay.
Yeah, this particular one is based. It's called a GTM30, or it's a GTR. GT. Get the name right. I want to get the name right for you guys. GTR, right? And and if you look really closely, it's an ARM Cortex something blah 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 STM something. but they're very lovely. They're very fast, and they don't get too hot. So and of course, with your 2209s now, it's like things are nuts. Our printers are so quiet and nice and inexpensive now.
Yeah, you take that extra per chip cost and multiply it by 4, 5, 6. Oop, starts adding up.
Yeah. Well, the great thing for these companies is they're probably, people they're like, well, since they're so inexpensive, I'll get 2 or 3. So they still end up spending just as much, but they get twice as much for their money.
Exactly.
I'll get a spare. Yeah, it's very cool.
Yeah, the 2209 is a nice chip.
Yeah, it definitely is. I guess there's a little bit of a push towards like the 2130 was another one that was popular until before the 2208 and 2209 came along, but it's not quite as convenient, I guess, to use. But it does have SPI on it, so you can talk to it through SPI if you really want to.
How much do we need to talk to the stepper drivers, though, really?
Well, that is the thing, well, the one thing that you can kind of do, I mean, they're pretty smart now on their own because they can check the amount of resistance and respond to it and things as they're running. But yeah, it'd be nice to be able to do things like tune them as to change that voltage dynamically, when you wanted to while you're running to kind of save a little energy. There may be times when you'd want to do that, and then I guess that's kind of what the Prusa's do when you go into like quiet mode and stuff. Is they lower the voltage a bit, and in addition to stealth mode. But I don't know. Is it just, or is it just they go to stealth and then not stealth? I must look into this.
I think
But,
I think they do have some. Well, maybe that was just
Stealth and
me.
normal.
Yeah, that's it.
Yeah, at least as of now.
Okay. Yeah, because it you could do a lower energy, low torque mode and save a little energy and maybe even keep your components cooler and stuff.
I seem to remember in the Prusa Marlin there was some kind of timeout for the Z stepper where it would actually go to a lower voltage mode after some time of inactivity.
Oh, okay.
It was
Yeah,
still
that
active,
makes sense.
but it would just go to lower voltage.
Yeah, that's not a bad
I
idea
seem to
in
remember
general.
that.
Yeah, that's a good idea in general. A little bit of safety in mind there too, because holding torque is like you don't need that much, and that's one of the areas where the steppers get hottest is while they're sitting there not moving. So that's really good, smart thing to do. If you could like put a thermistor on it and just monitor the temperatures of your steppers and respond to that, I suppose. But yeah, some of that stuff like that they've highly tuned for their machines, it would definitely be nice to have that as the ability to like get some tools built into the firmware so you could do that yourself, you know, where it'll figure out the movement limits of your things and where they, you know, hit where the stealth, you know, the stall guard gets triggered and things like that. Figure out and then basically just run a few tests and then have it say, okay, these are good settings for you. Here you go. Stuff like that would be just nice. I know that they don't exactly have that in Prusa, but they have something similar where it'll run the axis back and forth at different speeds and look at the way that the steppers are responding.
What about crash detection? I mean,
yeah,
how are they doing? It's been a long time since I looked, but that could be. That's not in mainline Marlin, right?
Not exactly. No, it's based on stall guard again, and it uses basically you set a level of that's even more like usually what you're trying to do when you do bumping the end stop is you want to set some level that is sensitive enough to detect that hit, and you kind of do the same thing, but you might set it less sensitive during the print, and so then when it notices that happening, then it'll respond by rehoming X or Y or whatever axis gets bumped. So yeah, and that's smart. If you've got especially if you've got a nice accurate homing system where and they're using sensorless homing all around, so it should be consistent, I imagine, unless there's a lot of weird compliance issues or something. But yeah, I think that would work.
Unless you have zip ties in just slightly the wrong position, which is what I've found happens.
Oops, yeah. You got to definitely make sure that you have a hard surface against a hard surface or something, so you can have something nice and repeatable. When I used to do my end stops, I would always mount them under the bed, like right where so that they would get hit by the actual bearing itself, metal against the switch, and if you hit the bed, it's got a little bit of play in it, and it's like, I'd rather have it hit right there where the belt is, So yeah, but yeah, that's good. It's a good trick, and overall in general, I would definitely, I'm aiming to get more of that setup stuff into Marlin, like, figure out your Z probe offset should be, a two-step process, and I just don't have it in there, so it's time to do that. Stuff like that would, just to improve that user experience. It's been a long time just crushing bugs, but yeah, that's where it really counts now, to get things to the point where they're working and then get polished up so that we don't look like slouches.
Well, I mean, there's a lot of things that keep coming in that I find are just kind of fun to play with. Now that I put SKR 1.4 boards on some of these old printers, right? The G34, and just doing the independent Z is kind of fun to just see it working,
Yeah, I haven't played with that much, mainly because I have, all my printers have Z's on one motor or one driver or whatever. But yeah, it'd be fun to play with that more. That's pretty cool, and it can augment your leveling a little bit, and ensure that at least your axis is fairly straight without doing like go to the top and grind or something stupid like that. Right?
Yeah.
So yeah,
I had that.
Go on.
I was going to say that the very first implementation of that was I think it came in bug fix right before Murph. Well, the last Murph that actually happened. And so on that big multi-head tool changer thing I had, because I had 3 Z-axes independently driven, I actually had that running on there way back then.
Nice. Yeah. Well, David, who actually helped implement that, was there, so we could thank him in person. It was great.
That would be nice.
Yeah. Go on.
I was gonna say since we're talking about Marlin, the question that I had for you. So at the beginning of the stream, I was talking about my current project. I'm trying to make a temperature logger using like an ESP 8266 on one of the Node MCU boards. If I wanted with 100K thermistor, you have in Marlin, there's the call it calibration. I forget what exactly the mode is, the command is, where you do the calibration of the sensor so that when you have sensors bouncing,
like M303.
Does that operation figure out the crap? I should have thought about this question before.
Well, it doesn't do anything like figure out if your anything about your thermistor. You have to tell it first off what it is, and so that it has the right thermistor in mind when it.
Right. So like I'm using NTC 100K thermistors.
Right.
When it's doing the calibration process, there's 3 values that you need in order to know what the heck the sensor's actually reading.
Yeah. The PID, it's called.
Is the PID the same as like when you look elsewhere for code, everybody references it as ABC or sometimes ABCD. Is that what that's doing, the PID?
Well, PID, it comes up in a lot of scenarios. The temperature is just one. It's pretty much any place where you need a control system that can maintain a steady something. So a steady speed, or against wind, or something is coming up against it, and there's some energy that it needs to add in order to keep at this thing. And when you add energy, you're going to get this thing called overshoot. And what you're trying to do is make sure that you add the energy at the right time so that it goes up at the right amount and doesn't
PID to the heater cartridge, not anything.
Exactly. Yeah, like if you had if the thermistor is far away from where the heat comes in, you'll get a more delayed response, and that actually counts into how the tuning works. But at the same time, having the thermistor too close to the heater means that you're not accounting for the whole heating area. So you have to a good way to mitigate that is to have more than one thermistor, one close and one far, or at 2 different areas so that they're averaging or looking in for the temperatures to both reach the same. And you can utilize that. But yeah, in general, what PID is doing is, you've got I always forget what P stands for, but the integral and the derivative are I and D.
Proportional.
The proportional, yes.
Yeah.
Yes, so proportion, of course, is, in terms of how much energy or how much do you want to add and how much do you have to add to get what you get. So if you're adding 1 and you end up getting 3, your proportion is sort of a 3-to-1 proportion. So you get that to get the right amount of energy you need to add to get it to react. And then you use the integral and the derivative are like based on observing and looking at the errors that occur and then basically trying to mitigate those errors in time. And so, PID is great when you have a steady system, but if you start to do things like with Marlin, of course, you're pushing filament through, which cools down your hot end, and the quicker you're pushing it through, the faster it cools. And that's not considered necessarily by default, but you can add that. And that becomes a C term that gets included as well. And there's a couple of different features that try to use the amount of filament moving through, and you can turn one or the other on, and they use different approaches, but try to do essentially the same thing, and same with the fan. If it notices your fan is on, and you can have an option that'll be, well, when the fan's on, I'll just assume it's going to cool down the hot end and add more heat. And so it tries to mitigate that. And there are other things
bumps up your P term.
Yeah, exactly. It tweaks the terms. Exactly. And that's those types of approaches are like, you call it maybe augmented PID or whatever. But yeah, the whole idea is in any control system, any engineering, PID comes into play. Even in things like bridge engineering, it may not be explicitly in a machine, but it comes down to how they arrange the cables things like that, based on, these balances of forces. But they do a fair job. Just with these three terms, it's pretty amazing how close it can come and how simple, when you look at the algorithm, how simple it ends up being. It's pretty amazing.
Yeah,
And
you do it has it Ziegler Nichols tuning. Um, it's really amazing.
Yeah.
Yeah, like Thinky Head says, just how many types of situations, really diverse types of physics, can be adequately, at least for normal human usage, adequately addressed by this type of PID code feedback, whatever you would say. A lot of that comes down to the fact that the physics itself can be addressed or modeled by certain types of differential equations that keep popping up all over the place. If anybody hasn't had a differential equations course or something in physics, I would look up some videos online on it. I don't know if anybody's got resources, but differential equations is the foundation of the PID loop. And you'll realize after studying this stuff for a little bit that the same equations that govern or that are derived to create the PID loops and the coefficients PID, where they come from, that same form of differential equation pops up in many types of control and feedback scenarios. You see it in HVAC engineering when you're trying to do airflow through rooms and cooling stuff down. You see it in chemical reactions where you're trying to control pH as buffers are added. You see it in insane wide varieties of industrial situations like that, all over the place. These equations are different and they come from different places, but they all have the same form. And because of that, they can be addressed really quite tidily by PID loops. And sometimes, like you said, you want a little augmentation, like a little delay factor or a little, here's a very repeatable, predictable amount of extra draw due to filament being added to the heater block. You can throw in extra coefficients like that. But other than that, yeah, PID shows up in a lot of places.
Yeah.
Yep. And it can, it's interesting that, when each time you reflash your firmware, you may have to recalibrate PID, because not only does it depend on, the variables you set, but it also depends on how often it gets sampled. And there might be slight tweaks in the timing from one version to another. And so you have to actually adjust for that as well. Sometimes you get those complaints, hey, my PID was perfect, and then I upgraded and now it sucks. It's like, well, M303, and then, maybe you have to hand tune a little bit. But there are a lot of great guides on hand tuning, and pretty much you end up just tuning the D term usually. But it comes down to, like, if you want to less overshoot, tweak this. If you want, more, of this, do that. And, you want more damping, do that. But yeah, and it's kind of interesting too that in Marlin, not only you have PID, but it's like a little dictionary of all kinds of common things that you see in all kinds of engineering. Like we have like the algorithm that does the line drawing is a very common one called Bresenham. The PID loop is in there. Of course, we have we have these Catmull-Rom approximations. We're using a kind of a bilinear approximation stuff. I mean, there's just like all these math classics keep showing up, and the stuff that we're doing junction deviation now, we just had to use a differential. Well, not what is it called? We're using an approximations. Using basically differentials. You're saying it's a continuous fraction. You 1 over this minus 2 over that, plus 3 over that, minus 4 over that, and you get these numbers that
like a Newton's method, or how do you compute that? That can be tricky to compute.
Yeah, well, we ended up doing we're doing a couple different techniques. One, I actually looked at some simple line approximation where you try to fit slopes to the curve in small pieces, and you just basically say, well, if the number's between here and there, use this slope. And then you just come up with that and use this slope here. And that was fine. It was probably fast enough. But someone came up with a technique that works twice as fast as that and but uses a table to do it. So, but the approach that we had taken was, let's see, I guess it's in, if I go to my, quickly take a quick look at that. Find junk, it's such junk. Sean DV, there it is, junction deviation, and there it is. Yeah, I'm using a fast approximation by Randolph Frank published based on min-max polynomial. So yeah, this one is it's actually an A sign, an arc sign approximation that we're using to then get an arc cosine approximation, because you just shift it over. So yeah, and then basically that was what we're using, and it had ended up with 6 multiplications, no divisions, which was
Wow.
nice. Something like that. 1, 2, 3, 4, 5, 6. Yeah, but nested, so you take the product and then multiply it again. So it ends up looking like you're going through, squaring, but you never do, because you're scaling the t term and then subtracting, then adding, then subtracting, then adding. But yeah, it's pretty neat looking little equation. But the new one is it uses, I think, 128 bytes of RAM, or 120 bytes
That's
of
amazing.
RAM to do its thing. So it could probably fit, even on an older processor, if you squeeze a few things out that, so heck,
I want
that's
to see this code. What's the name of that
oh well,
subroutine?
let's see, it's on line 2315 of planner.cpp. There you go.
I gotta check this out.
What's it all about? Asyncs equals blah. At least in the current code. I don't know what one I'm looking at, the right one, but maybe I am. Let's see. Oh no, that's last week's. No, that's fine. But yeah, it's what's called a polynomial, min-max polynomial, and yeah, it was. But the problem was that at certain weird spots in junction deviation land, you get strange accelerations, and that was due to the previous approximation having a high error in a certain range, and so we went to this one, which has a sort of a sinus error. It's very small, but it's sinusoidal. But with the new approximation, there's like almost no error. It's looking pretty good. Yeah, I'm pretty excited about that, because it's been a headache, and not knowing the answers always bothers me. It's like, what's causing this strange anomalous thing? And then suddenly people come up and they know things and explain it. It's great. This particular one was definitely tricky. Compared to the laser stuff, much trickier. And yeah, so the newer one is, I'm just checking out, is just posted today. And this one is called he's not giving it a name. It's based on a table, and lookup table, and then someone's doing a test on it. We have a guy who's very good at testing these things and makes sure that we're being honest with ourselves. And yeah, it looks like, yeah, it looks pretty good. But yeah, lookup table, well, that's the method, that's cheat, but I consider it a cheat. But I posted a picture on Twitter of the error, the difference in the error. And, if you're at all curious about that, it looks like, I need to open my system preferences.
Hey Scott, since you got your lookup table there, where is the code for 100K NTC 3950 thermistor?
Let's see, an NTC 39 thermistor. Let's see.
Because I'm going to steal your code for my project.
Well, let me just take a quick look at what configurations. I mean, I have to kind of just look at what the list of them are.
I was looking at the thermistor tables.
Yeah, wow. and I'm looking at, like, so in the config, you've got this thermal settings area, and in it we have them listed with numbers. But so let's see, ATC Semitech. Do you have what was the brand name on that again? NTK.
It's just a
Oh, I see.
Some Chinese. I bought 100 of them for replacements.
I see.
TC,
They're almost
temperature
always,
coefficient.
thermistor 1 is almost always correct. But if not 1, usually it's often 5.
It's you say 1 or 5.
Yeah, 1 and 5 are the most common.
Okay, and that it's the same thermistors that Creality is using.
Yeah. So the number 5 is used by A3D and some others, so it might be the more pricey one.
Okay.
It's usually the one used that some of the Crealities are using in the bed. I believe.
It probably is. Yeah, it's the little glass bead style one. I was thinking that might work, but the coefficient's 3950. Dan,
Yeah,
I'm
okay.
having issues playing with one that I'm trying to do for a temperature logger that I couldn't get accurate readings on what the actual temperature was. Like I had a calibrated thermistor next to it with a meter and just get within even 10 degrees. So I'm kind of looking to see what Marlin's doing to get it.
Yeah, well, if you put it in boiling water and you get exactly 100 degrees,
right,
you're a winner. But yes, it's that's one good way to test it if you don't have a laser thermometer.
Yep.
And other than that, those I would go for those first if it's like way off. Like it should at room temperature say 21, 22 degrees at this time of year. So I would go with that.
Okay.
Yeah.
I will say that I don't remember what project it was I was working on, but I was like, you know what? There's all of these Marlin macros. These are pretty good. I'm just going to take all these.
That is exactly where my mind went, Paul. With this project, I'm like, Marlin probably can account for everything except for a one-wire thermistor, or temperature sensor, I should say. That's not a thermistor. So I'm like, shit, because I want to use 10K thermistors.
Actually, it probably can. I mean, I think there's I2C temperature, isn't there? Yeah. So.
Oh, okay.
Yeah, you can use thermistors or thermocouples.
You got one of these, right?
Yep.
Yeah, we have P-type, K-type, you name it. We got all the types.
Yeah, and I'm like, I can figure out the legwork to do this. They've already done it. Marlin, I can just rob it.
Yeah. And of course, we support the ones that pretend to be thermistors as well. So,
right.
Those work fine because they just prevent a nice interface. But yeah, they're cool. They're very cool. Later.
Oh, I bumped my scroll wheel. Dan, this might be a better question for you. What's a Hisense thermistor B25/50 equals 3950?
Isn't that the resistance value at 25 degrees C?
Yeah, that's kind of like your intercept, isn't it? It gives you a starting point. The coefficients change your slopes.
Oh yeah,
from there.
Another one that's 3950 as well. Okay. I was just that 3950 jumped out because that's what I have is 3950 100K sensors. Sorry, I'm sidetracking this with my project. That has nothing to do with 3D printing besides the case.
Yeah, so that link just shows the LUT, the lookup table, if you want to check it out. But it's fairly
looking at it.
Straightforward. The generation he's got some code that he wrote for MATLAB and then translated to C. Give us an idea of where it's coming from. And and I was just I wanted to just confirm the numbers before I then committed it because some of them were disputed. That first value doesn't look right to me. And then where does the error? Does it err on the side of faster or slower? Err on the side of a bigger angle or a smaller angle. And then we had a long discussion about the merits of junction deviation in general when you're using a system that has decoupled axes.
Like
even though all the Mendels are basically have a moving bed that has a different weight than the carriage on the X, and usually that means that you can you should be able to slam the X around much faster than you can slam the bed around. But at the same time, like you are always getting a deflection in the opposite direction of the combined motion, in the whole body of the machine or the table itself. And so does it, is it because is it that we're trying to counter those reactions in space, or do we care about, or is it better to use jerk just because those independent motions are the only ones that count or matter? And really,
Yeah.
if you look at if you do it on the basis of jerk, you kind of end up with the same effect. So it is interesting, but with a simpler algorithm. And it'd be interesting to just compare those two and really look at the boundary of, where are the boundary conditions where they meet up, really nicely, and where are the places where they diverge a lot, and what happens in those scenarios. And it shouldn't be hard to run the numbers since we have all the code right here in our laps. It just hasn't been analyzed that way yet.
Yeah, under a lot of situations, they behave very similarly from a human scale perspective. One of the only places that I would notice issues is in extrusion behavior, specifically when you're adding linear advance. I found that junction deviation. Yeah, exactly, because of discontinuities and.
Sure, and add S-curve acceleration, and
Yes.
then you have time differentials, and everything is lost.
Then everything.
The thing is, the thing about S-curve is it should be deterministic, but we don't have a predictive algorithm that tells us exactly how long it's going to end up taking compared to the normal, because it's just done, it's sort of it's a dynamic method. But if we could predict exactly the duration that would be added in, then it could probably correct for the problem with the extrusion. On the other hand, those dynamics of slowing down your deceleration and stuff, are going to give you some, perhaps some slightly weird looking walls in those little areas, but it's hard to say. Because you're dealing with two different problems, right? You're dealing with the springiness of the filament on the one, and the pressure that's built up, and then you're dealing with the shaking of the axes and the ringing and all that on the other.
Two vastly different sets of equations, and you're trying to constrain them to be synchronized together. It's okay. Now it's one big, complicated, doubly complicated set of equations. Find the solution here.
Yeah, it's
that's
like
non-trivial.
It's trying to have an omelet that you can then take apart into its constituent pieces.
It's hard.
And you do end up with those kinds of funny dynamics too. It's like the double pendulum. You're going to get a swing that looks great, and then suddenly, what the hell? Where did that come from? That's what I do worry about. It
doesn't take much to make chaotic behavior. You can get some really weird emergent behaviors out of some very simply coupled simple systems.
Yeah, and then we have the low level steppers and things themselves now trying to be smart. So who knows what happens when you add that in.
But in some of these
imagine
cases,
if they're doing torque curve compensation, then it gets really weird.
If you had feedback in some of these cases, though, right, then you could work with that dynamically, and you could have better adjustments, right?
Yeah, and honestly, we should have some. The modeling of masses in motion that if we're not trying to deal with tumbling and things that are going to act weird. We can model these fairly straightforwardly in get out our Unity and whatever, and just see what happens when we simulate it, and have things like put some glitter on top of it and bump and make the axis move in such a way that the glitter never falls off. That'd be ideal. But can we get to that point? That is the question. And is it really the ultimate goal? Because if you have a very, very well constrained machine, then it doesn't matter to a large extent how much, because the forces themselves, they don't go anywhere. They go into the whole table, they go into the surrounding air, and that's it. That's the trick, is where do the trade-offs come in.
Right. Software engineering as well as hardware engineering. I come more from the hardware side, but even software engineering is a big exercise in good enough, right? Any engineer, any layperson for that matter, can build a bridge over a stream that stands forever. You just fill the whole thing in with concrete, but it takes an engineer to build a bridge that just barely stands, right? You don't invest more material than you need to. That exercise of making something just good enough to where it's not your limiting factor, your bottleneck, your issue causing issue.
Yeah.
That's engineering, man. That's where it
Well,
comes in.
I'm kind of like Neri Oxman's approach to engineering, where you build the bridge in such a way that parts of it are going to fall apart, and you let them fall apart, and then you spray the parts that didn't fall apart with resin, and then, little by little, it builds up into something which has its own. The parts that are strong and need to be strong are reinforced automatically within the system itself, and sort of like taking the some kind of algorithm that you run, like that thing that Tom did with his shelf thing holders, taking out the negative spaces where it didn't matter that there was material or not, and keeping it reinforced where they needed to be, but letting that happen naturally is kind of cool. And that the code can work that way sometimes. I do like to be a little chaotic in that way, let things elaborate into a big mess and write a giant piece of code with a bunch of logic to it. And then eventually you see the patterns and you can break it down into those things. And then you realize you don't need 20 components. You can use one multiplexer, or whatever it might be, to do that simple thing. Well, Steve Wozniak was a genius in that area in terms of repurposing components for things that they maybe weren't initially designed for, but just they turn out to be perfect in this situation. And that's what we do.
We wouldn't be where we are now if people weren't repurposing stuff it wasn't initially made for.
I know,
I love
right?
repurposing stuff.
Totally. It's the rep way.
That is the rep way. That's the spirit of our kind of bootstrap garage tinkerer,
Yeah, it's funny because getting into 3D printing kind of went back to salvaging electronic components from VCRs, old computers, like desoldering parts to reuse elsewhere. It's like, it kind of justified that whole being cheap, so to speak, solution. Everything that I did leading up to this, it's like, hey, that all makes sense now. I'm just looking at the chat. The chat has been keeping me and Chris entertained.
Oh, I have not been following it. How are
Ron's in there. So apparently, Chris, do you actually have a pair of 3D printed loafers?
No.
Okay, you made the comment that those aren't comfy.
No.
But Ron threw back. He said,
No, I just said that because Joel got a pair
right.
of those, and he said they just weren't comfortable.
Yeah. And Ron, the happy extruder, replied back. He said, click them 3 times and they'll take you to G28. So we've been kind of like, there's puns flying like crazy. And Brian Vines is nowhere to be found.
he's missing out.
No, he took off a while ago. He said he was taking off.
Yeah, I know, but all the good puns are coming out, and Brian's
Gotcha. Okay, gotcha. Okay, you're right. Gotcha.
Oh my.
Yeah, what was he doing punting like that so early?
Oh.
All right, sorry.
I can't imagine that loafers would be that comfortable. I wouldn't mind having a 3D printed smoking jacket, though.
What was that?
Didn't
have a what?
A 3D printed smoking jacket.
Smoking jacket?
That's a thing.
John Pickens had insoles, right? At Murph. 3D printed insoles that he'd done. Like there was some like online thing where you'd scan your feet and then they'd give you an STL to do insoles for your shoes or something.
Yeah, what was his name? Cool. John
Pickens.
Yeah, that's a really great application right there. That is sweet. I'd never thought of that one. And I wrote down 100 when I first discovered 3D printing. Oh, look at all the things I'll be able to make. Let's write a whole list. I've made about 3 of those things since then. But yeah.
I've thought about it with having like the CR10s and stuff. I mean, I don't have like ginormous feet. I've thought plenty of times about trying to design a pair of sneakers and just print them just to see how horrible I do. Like, I could probably do it. They probably wouldn't be comfortable, but they would look like shoes.
Yeah, I mean, everyone should do. I think as just a project, do a pair of shoes, do a wig, a hat, do a.
Well, I just put the Hamera on the Robo, so that means TPU fun can kick off.
Oh, nice.
Full speed TPU printing, none of this 25 millimeters a second crap.
Just
I'm gonna,
think you take that and combine that and your palette together.
Well, the palette that I'm stuck at, you're capping at 40 again.
Oh yeah.
Oh, is that the palette's limit?
That's
Standard.
the palette. Yeah, unless you get the Pro. The Pro.
I don't even know.
Pro,
I
you
have
get
the
back
Pro
up
and
to
don't even know what it
60.
maxes out at. And I just have the Pro, not the Pro S or whatever the new version upgrade is.
Yeah, I guess there's a sensibility in that. There's a thing where that the filament follower probably gets a little screwy if it tries to go too fast.
Yeah, it has that buffer area, the buffer zone.
Yeah.
And I've printed too fast for even the Pro and sucked that down, and then all you do is end up snapping the filament because it's trying to make that real tight bend. Then.
Yeah.
Huh. That would work at the.
You gotta. It takes so long to get. Some of those spots you get splices back to back.
Yeah.
If it's too short a length, and at that point that can be problematic.
Oh, so even getting the RC Maniac just posted in the chat, the Palette 2 S Pro is maxed out at 50 millimeters per second. So I don't think my Pro can go any faster than your standard in the non-upgraded version.
I wonder what the Chameleon can do. It's got a standard straight up step. It's fairly simple compared
Chameleon,
to
I don't think has speed limits really. Now, 50 millimeters per second for the Palette Pro. Are we talking like linear filament dispensing speed, or are we talking like XY nozzle movements, printing movements? Because I
think that's in reference to XY and filament extrusion, like your print speed. You know how you basically, unless you're going in and really tweaking your slicer settings, you're just saying I want to print at 50 millimeters per second. And I would believe you'll probably max it out because I keep wanting to put my palette on one of the CR10s while I have a 1.0 nozzle on them right now. And I'm like, they would print way too fast for the palette to keep up.
Yeah, that would be an exercise in frustration.
Absolutely. I did find, though, printing with the 1.0 nozzles, I've been using a lot of like the leftover, what's left from the spool when it runs out, and splicing those together, spooling it up, and then printing that through them. That's been working well. Interesting results. No purge block, no nothing. No accountability for the fact that it's going to change colors.
Yeah, I haven't played with those yet, but I look forward to it. That's a pretty interesting device. I was very excited when I first saw that because it was, it's a way to take your very simple single nozzle machine and turn it into something, with more stuff.
Yeah.
But then, so many different approaches to that. It's amazing. Prusa's approach, and very cool.
And Scott, I was going to say for the Chameleon, I don't think you have that issue because it's not doing that fusing.
Right.
I mean, it's the whole.
It's more like the MMU2, right? You're backing off.
Yeah, exactly.
Yeah, you're backing off, and you're
or
jamming
actually more like the MMU1. I'd say probably.
Yeah.
Yep. With a light, it's highly refined, but it sounds like that. But essentially, So it's interesting because ultimately the palette is, it's very, very much all self-contained in that one, unit. It's got so much going on in it, and the fancy screen and everything. So I mean, it's definitely a highly engineered, highly integrated unit. So you're getting something that's it's very professional. It feels professional, and it looks great on the wall.
Just the small package of it, like the fact that they've got 6 stepper motors crammed in that thing, 6 extruders crammed into it, basically.
Yeah.
Even though it's 4 inputs, so you have 4 extruders there, and I think there's at least one more extruder built in. I think there's actually 2 of them in there yet.
Wow,
So
brilliant.
just the fact that that's all crammed into that tight area. And
I
that
mean,
the
that's
form
why
is
that thing
big,
is
that's
so
not-
dang heavy.
Oh, I know. And
Yeah,
that thing is a beast.
Solid metal.
Yeah.
Feels like 2 bricks.
Yeah. Every time I go to pull it up out of the mount on the wall, I'm like struggling because I'm reaching over top of printers trying to do this with a 3-foot wide table. And it's,
Oh man, you need to hang it on a rope so you can just
yeah, pulley system. That's almost what I need.
yeah, set up pulleys.
What happened to the was it was like was it
RC
Crane
Maniac
3D or
confirmed.
something that was from they were at
Oh,
Earth
yeah.
2018. They were doing like CMYK trying to
No,
do
it's,
Yeah.
what
Yep.
was that?
oh goodness.
3D.
M3D.
M3D, yeah.
M3D.
They're the ones that did the box, and then they have their crane quad
Yeah.
mixing setup. And yeah,
Yeah.
you're right, Paul. They had it set up, and those printers didn't run the whole time they were at the show.
Yeah.
Yeah. They were cool though. I mean, the idea of mixing CMYK was, it's sort of like obviously very tricky. You don't get a clean mix. You get that what's the Colgate effect as they call it.
Yeah.
Yeah, it was always
Yeah.
everything I ever saw demos of that, like pictures, was
Right.
always just like a clouded, faded look to the color mixing.
Yeah.
It was a neat idea. Like it would have been awesome if it worked, but like Chris said, at Earth when they debuted that, it wasn't running.
And I'm not an electronics guy. I don't know the hardware side, the little stepper motors that they use on all their machines.
They're pretty marginal. Not gonna lie, I'm not really a fan of that
They're
particular motor choice.
yeah, and they're those little round stepper motors with plastic. I think they're
Hmm.
plastic casings, and that's what they use for everything. And they're just
Hmm.
it's odd, and it smacks of closed source to me. It's just not.
By the end, I think they were metal casing and metal gear, but the damage was done. They're clearly trying to just scrape up to find what's barely adequate. And in the real world, where a lot of us are using these, not in the land of theory, but on planet Earth, stuff goes wrong, and you need a little extra torque. You can't count on everything to go right all the time, and they might have worked in the best case scenario, but I mean, see what happened at Earth. They were kind of unable to demonstrate their products because they were built for the barely working minimum.
Right.
It's
That's
tough.
my brother's first printer was the M3D, the Cube.
Oh, my condolences.
And when he stripped the gear on the stepper, because that one was using plastic gears on that little, basically an RC stepper motor.
Yeah.
I got it from him. I put a weight extruder on it. It's hanging off the side of it. I hacked the thing apart and put a weight extruder on
Cube extruder.
it. Pretty much, yeah. The extruder was almost the size of the printer. And then did a Bowden feed into the hot end.
Damn.
Yeah, I don't think they had any of their printers running at all that weekend, because they also had their high capacity machine. I think it was like 1.5 by 1.5
Mega.
Yeah,
Pro
the
3D
Mega.
Yeah.
Yeah, the one with the four, they had 4Zs with the 4 little stepper motors, and it had a tricky motion system to it too, Scott.
Is that the one that
really?
they co-developed the Duet 2 or the 3, whatever the new Duet was? Was it for that machine, the Pro Mega?
There
I
was,
think-
yeah, Duet was involved, yeah.
Duet was
Yeah.
involved. Okay.
But yeah, they also had a funky motion system, kind of like a Core XY, but not.
What was it, Mark Forged or something? The Mark
Was
Forged
it really?
system?
I thought it was. I
no.
thought it was Core X5, but maybe it isn't. I have
Maybe
to look
it
this
is.
up. I love kinematics, man.
Mark
why-
Forged would probably be the last thing they would have used, but
Yeah, this Not a fan.
Or-
So
Yeah.
anisotropic. Just why? If you've got Core XY or other things, just stick with that.
The basic
Yeah.
idea of Mark Forged is similar to Core XY, but it has one of the steppers moves like one axis, and then the other they move together to move the other one, which is weird.
Yeah. So your map coordinate system ends up being like one here and 145 degrees is your coordinate. Instead of two perpendicular, you get one straight and one skewed. This is a wonky way to do it.
Oh well.
Oh,
So
I'm trying to
did
look for
they
their
did they
belts.
generate like did they have Kickstarters or something? Was that how they were
Mhm.
operating? everything?
Yep.
So what about Creality initiating a Kickstarter for what is it? I don't remember what the
They
name of it is.
announced, yeah, they announced it, but it
Success or
sounds
something?
like, yeah, it sounds like they won't be allowed to because they're not in one of the countries that Kickstarter permits to.
Yeah,
Ah.
that's what I'd say from it.
Unless they're running out of Hong Kong, but I don't think that Shenzhen and Hong Kong are quite. If you're working out of Hong Kong, you probably don't have a company in Shenzhen, and if you have a company in Shenzhen, you probably don't have a subsidiary in Hong Kong. I'm just thinking. But although it's hard to say, China has reclaimed Hong Kong recently, right? A few years ago, but they haven't, turned it into, a walled enclave of China yet. But as I understand it, yeah, they probably won't be allowed to do that. So it's kind of a moot point, I think. But it's curious because I mean they're sort of trying different things. But a lot of companies do that. They're maybe just trying it as a publicity thing, because some companies have done that for publicity purposes. No one's ever heard of them, but then they're on Kickstarter, and then people hear about them. Crowdy maybe is pretty famous to us, but I don't know how well known they are in the wider world. And I did work for a startup that was a Kickstarter at one point that didn't succeed, or at least is on hiatus. And like, how these things go. They have some big idea, but it turns out maybe it's not as unique enough, or whatever. But there have been a few success stories. There were a couple little printers, but that came out of Kickstarter that actually did pretty well for a while.
Printerbot was one of those, wasn't it?
I think so.
Yeah.
The early wood one, and then that kind of kicked off the wave of Kickstarter printers. But then we got stuff like Tico and what was the resin one that was supposed to use your phone?
Oh no.
Oh no!
Olo
Yes. Oh
and
no!
Ono.
Olo,
And then they
oh,
changed
no.
it to Ono. I'm like, really?
Yep. RC
Nice.
Maniac has a
Where
yeah,
was
yeah.
that? Was Maker Faire New York 2017.
Okay.
But they actually had the Ono printer there printing, which was like the first time you actually saw models coming out of the printer. And I had talked to them this last day of Maker Faire on Sunday before we left to come home, and ended up with, throughout the day, they were texting me, letting me know what problems they were having at the time. Like they were supposed to be, I was supposed to shoot a video of them with the final print coming out of the printer, okay, as it finished, basically.
Yeah.
And through the day, I'd get a text message, hey, the print failed. A little bit later through the day, I'd get another text message, hey, the print failed. They were still texting me. I drove from New York back to Pennsylvania, and they were still texting me at like 1 or 2 o'clock in the morning from their hotel room, letting me know that they continued to have failed prints. I'm like, guys, I ain't coming back to see this. Like, I'm done. And this was like everybody had already sworn them off, and I'm like, well, look, for once we finally see printers at a Maker Faire instead of just pictures. I'm like, they at least have something working here, or they would have never brought a printer that actually is doing something. So, here's like your last chance. This is your last stride to make this work. And they failed horribly at it.
You'd think they would have brought 2 or 3 units just so they could have them all
They
Yeah,
did.
One
They had-
fails, the other one doesn't.
They had a
Yeah.
couple, but they just kept failure after failure after failure.
Well, I had nothing to do with the firmware, so at least I know it's not my fault.
Yeah.
All right, guys, I'm gonna bail. I'm getting
All right, Paul.
tired. So it's great talking
All
with
right.
everybody. Take care.
Yep. Thanks
Right
for
on.
joining, and I'll get in touch with you about my idea.
Yeah, sounds good.
I think I want to try, if you're willing to work with me on it, I'd like to try what you're doing locally,
All
possibly.
right, yeah, let's do it.
So, all right,
All right.
cool. Thanks,
ya.
Paul. See
All
you.
right. Night, Paul.
And I'm gonna run right behind Paul.
Good grief. One leaves, they all leave.
Yeah, I hate to say.
Dropping like flies, tired flies.
right,
I think I
Chris.
better hit the hay too.
Started a
we're all
trend.
Well, look at that. Well, why don't we all just do our outros then?
Yep, absolutely. Go for it, Chris. You go ahead and start your outro.
All right, Chris here. I'm Chris P1. Good night, everybody. It was great talking. I hope I entertained some people tonight. Yeah.
Can anybody impersonate Paul? Do his outro.
Paul, you can find at PPOC Stylus everywhere. Twitter,
Yeah.
except for GitHub. It's something different on GitHub. I forget what it is.
Hi, John.
It's about right. It's Pauxtilus.
Is it?
No,
Okay.
no P on the front. Just the one P.
Okay.
Yeah.
There you go.
Something like that.
So that's Paul. He's the one who left early.
Yeah.
Dan,
Right.
go for it. Hey, Dan. Go ahead and do your outro.
Oh,
Yeah,
mine.
sorry.
I'm Dan, aka Techie Fiddler, on all of social media except GitHub. I don't have a GitHub. Is that social media? It kind of counts nowadays. Anyway, I'm getting back into printing after a couple months of not doing too much with it, just kind of being active on Facebook, all that sort of stuff. So looking forward to getting back into some projects here.
Right on. And I'm Scott Latane, Thinky Head, your friendly Marlin geek, signing out. It's been fun. Find me in GitHub, find me on Twitter, find me on Facebook. But you'll probably find me absent because I'm in a dark room coding.
And you will find Scott on Patreon as well.
Oh yeah, Patreon. I almost forget to mention, but yeah, GitHub has been a really great boon lately. They're doing sponsors, and that's been a really great thing. So join a sponsor and Patreon or on the GitHub. They're great. Both great options.
Cool. I always try to make sure, Scott, that you plug Patreon or ways to support. So
There's never a shortage of work. So yeah,
Yep.
we'll be here. We'll be here.
And of course, you guys are all watching the Friday 3D Printing Community Hangout. The next Hangout will be May 15th at 10 p.m. Eastern. Probably going to just do another general Hangout while everything is kind of shut down for the most part. We're staying away from the host or the guest and topic style streams. Those will come back when things go back to some kind of normal. But we'll probably just do another Hangout. It's nice to do this to just get a break from everything else in the world right now. So thank you everybody who came on to as a panelist, and thank you to everybody in the chat. And Chris, special thank you to you. You kind of like taken the reins in getting things organized this week and just to push for the stream. So
I just said there'll be a stream, right? And people jumped on the bandwagon. So
That
Organize it,
counts
guys.
as getting organized. I mean,
if you
hey.
didn't like tonight's stream, you can blame Chris.
me.
If you like tonight's stream, blame Chris. And I'm pointing over here because he's right there on my screen. I don't know if he is on YouTube. I'm not watching that part. But yeah, thank you everybody in the chat for joining. I had a lot of fun paying attention to chat, and sometimes you guys drew my attention away from the conversation, so I apologize for that. But thank you everybody, and stay safe, and we will see you in 2 weeks.
Thanks, Matt.
See ya.
Good night, everyone.
Good night.
Night all. Wash your hands.